Hey,
What?
I've really been learning a lot about statistics, and I just started to see how it relates to my everyday life.
No, duh, it happens all the time. For example, the other day, I was talking to my sister about the weather in Seattle. Did you know it fluctuates more than what people think?
Really? When I think about Seattle, I always think it's raining.
Well, it turns out that the standard deviation for the number of rainy days per year is large. A large standard deviation suggests that some years it rains a lot and some years it doesn't. It depends on the year. I think she understood, but then she asked me if the year was a strange year for Seattle or not. She says that it seems like it hasn't been raining too much this year.
Well, I guess we can compare how many days it has been raining this year against the average number of rainy days per year.
But what if it has only rained one less day than the mean? Would we then conclude that it has been a strangely dry year? How many days would it take to seem very different from the average?
I think there may be a way to figure that out using the standard deviation. We should use this standard deviation as a tool for measuring how different this year's rainfall is from the mean.
Oh, that would make sense. If the standard deviation was small, then even a small difference from the mean would suggest that this is a pretty different year. But since the standard deviation is large, it would take a pretty large difference for us to conclude that this year is very different from the other year.
Yes, so instead of measuring how different this year is from other years in rainy days, we can measure it in standard deviation.
Whoa, you lost me there. What do you mean, measure in standard deviation?
Well, let's say it rained 80 days this year, but on average it rains 86 days in a year. If we thought about the difference in the unit days, that would be 6. But we need to know, is 6 days a big difference? So instead of measuring the difference in days, we should measure it in terms of standard deviation.
That sounds a lot like calculating the z-score, because the z-score tells you how many standard deviations the score is from the mean.
Yes, let's look at the formula for z-score and see if we can make sense of it in this way.
It seems that here you have the distance between the score and the mean.
Yes, but you have to remember that this difference is in terms of the measured unit, in this case, days. It's not in terms of standard deviation yet.
Oh, so that is why we divide by standard deviation. That's sort of like telling you how many standard deviations fit inside the distance. It's almost like we're using standard deviation like a new kind of ruler.
Exactly. In statistics, that's how important variability is. We want to use it as a new kind of ruler.
So let me see if I can get this straight. The z-score tells you how many standard deviations the score is from the mean. So if the z-score is 1, that means that the score is exactly one standard deviation above the mean. Can z-score be negative?
Sure, why not? If the score is below the mean, the z-score will be negative. So in your Seattle situation, if there are fewer rainy days than normal, the z-score will be negative. Also, if you know that the number of rainy days per year are normally distributed, you can use the z-score to figure out exactly how rare this year is.
Okay, I'll draw normal distribution just to try this out.
We can even use the Seattle situation as an example. Let's say that the average number of rainy days is 86, but the standard deviation is 15. How do you label this in days?
Like this?
Yeah. Now, how would you label it with standard deviations?
It looks like I'm just relabeling the graph.
You're right. We are just making it easier to see and talk about standard deviations.